So today we wanted to talk about pesticide formulations. This is how, in fact, we should start asking ourselves, what is actually a pesticide? What is in it which makes it a pesticide? Once we address that question, it may become clear what pesticide formulations are and what they can do, what is their function. So the formulations represent the form or status in which the pesticide is sold for use. I am sure you are aware of some of these pesticides, how they are being sold. We are going to get to the bottom of this issue. First, we should understand what is a pesticide. It consists of what is called an active ingredient and the inert materials. Please note that the active ingredient is the chemical that does the job on the pest. It is the one which can kill the pest, whereas inert materials may not be harmful to the pest. Sometimes we talk about the concentrate, part of the total formulation made up of the active ingredient, expressed as a percentage of weight, and is always stated on the label, or it should appear on the label. So we should always remember that the pesticide has got an active ingredient plus inert materials. Common formulations are either liquids or solids. If we can have those two divisions. This is normally how we see the pesticides. Others are solids, some are just liquids. Now, what we call inert materials, these could be adjuvants, additives in low amounts that improves or enhances storage or handling of active ingredients. Surfactants, these can be spreaders, stickers, emulsifiers, and wetting agents. They make the pesticide efficient in doing its job. We also have anti-drift agents, color odor additives to discourage ingestion. Maybe we put coloring just to warn people that this is a dangerous substance. We may also put antifreeze or other stabilizing chemicals to promote storage. Probably antifreeze could be used in temperate climates. Later on, I will be back to talk about inert materials. This is what I'm going to do probably at the end, just to unpack some of the issues concerning inert materials. So a single active ingredient can be sold in various formulations depending on the target pest. So please note that the types of pesticide formulations are generally categorized as solutions, which is a liquid. We also have emulsions, which are also liquids. Dry formulation suspensions, these are also liquids. Then you can have granules, maybe powders. Probably I've also left powders, which is important. Now I want to talk about certain formulations which are in the form of liquids. They are actually solutions. It's actually a solution which is being sold containing this active ingredient. Now there are two types of solutions. There is a solution which we may call water-soluble concentrate. It may be regarded as a SC. We also have soluble powder, which may be regarded as a SP. And indeed, we may have another pesticide being called soluble liquid, being represented by SL. So solutions, you have the formulation which can dissolve in water to form true solution. Herbicides or pesticides which are formulated as soluble concentrate can be formulated as soluble concentrate, soluble powder. If it is soluble concentrate, we call it SC. Soluble powder, SP, or soluble liquid, SL. Maybe later we'll also talk about soluble liquid or soluble powder. Water is the carrier. We mix, we use water to mix these pesticides. Herbicides, for example, amine, ammonium salt, or mineral salt can be easily dissolved in water. Therefore, we may not need what is known as the agitation, that is mixing, where you have, when you are pumping, you have something inside the sprayer which is actually continuously mixing the solutions. So agitation for these solutions, it may not be necessary to maintain either pesticide or herbicide solution. If these are the pesticides like the Arsenal, Roundup, and the Todon, they can easily dissolve in water. So this is it for solutions. And let us see the kind of labels, how they appear. Glyphosate, it's SL. If I go back a bit, SL means soluble liquid. It means you pour in the liquid in water and it easily forms the solution. Again, paraquat, another SL, soluble liquid. Another glyphosate there, SL, soluble liquid. It looks like most of these herbicides are soluble liquids, bendazone or basagran. Then we move on to emulsions or emulsifiable concentrates. I mean, those which form solutions actually are easy to work with if you are measuring their quantities, unlike these emulsions or emulsifiable concentrates. Emulsions are like chemical bridges between droplets of oil and the body of water. You have linear molecules with hydrophilic water, loving head, and lipophilic oil, loving tail. This is the chemistry of the nature of these products. So when oil and water are mixed, they congregated the interface between the two liquids. But one of the characteristics of the emulsions, which you should remember, is that the mixture has a milky appearance. When you have mixed the two, it appears you have got some milk. Not if growth regulator herbicides can also do this. So when you are mixing emulsions or emulsifiable concentrates, one of the indications is that they form a milky appearance. When we represent an emulsion, let me try to admit someone. Okay, let me go back to the presentation. So, like pre-foreign, this is a herbicide. I don't know whether it is still being sold to those who are at agriculture. 30 EC. But what we are interested in is the EC label to tell us that this is an emulsifiable concentrate. So if we are mixing, we expect a milky sort of appearance in the measuring cylinders. Secope 360 EC representing emulsifiable concentrate. This is I think Galaclo 960 EC. Again, EC on the label indicating emulsifiable concentrate. Proper Quizafop, I don't know whether these websites are still available. 100 EC, again representing emulsifiable concentrate. Agile, these are the new herbicides, I think. Agile 100 EC, again an emulsifiable concentrate. So we have emulsifiable concentrates, which you have got a bit of oil, and if you mix them with water, they form the milky appearance, and I've given you some of them. But in order to recognize either in a hard way or wherever the chemical is being sold, EC will represent an emulsifiable concentrate, and it is representing the formulation in which this product is being sold. There are advantages and disadvantages of different formulations. One of the disadvantages of the EC is that it may be difficult to measure because of this milky appearance. Liquid flowable, liquid suspensions, formulations. Liquid flowable formulations are highly viscous. If we say they are highly viscous, when you are trying to measure, it's very difficult to pour them in a measuring cylinder. So they are not easily poured. Liquid flowable or liquid suspension formulations. A slurry or a paste formed by wettable powder and water. Liquid flowables separate during storage. So you have heavier particles settling at the bottom of the container. In other words, if you are going to use them, probably you have to shake that container before you do some measurements. So this may require careful mixing before use. And when we do this, we should always be aware of safety regulations when entering these chemicals. Atrazine is one of the examples of a flowable herbicide. You can see what is written on the label, which could be, again, someone wants to join. Let me admit the person. Okay, sorry for that. Let's go back. Now, atrazine flowable. Yeah, sometimes they write it in full, but sometimes they just write it in abbreviation FW. Gesaprim 500 FW, representing a flowable. I think this is Gesagard 500 FW. Again, someone wants to join. Okay, just bear with us. So FW means flowable. So if you see a label with an FW, that is what it means. It is indicating to the formulation. Gatomir 500 FW. I don't know whether these products are still there on the market, but I mean, you can always see new products. Some of you are in the trade, maybe you will tell us more about some of these things. Gesapax 500 FW, again meaning flowable. Now I will move to talk about dry formulations. Normally I don't want to work with the dry formulations. Now, if you see a label with a G, it is referring to the granule. This is ready to use mixture of a small amount of active ingredient with inert carriers. Pesticide is absorbed into the granule. It can be used for soil treatment, not mixed with the water, minimizes drift. It's ready to use. But large quantities, this is the disadvantage of granule. Large quantities may require expensive transport. I remember in this country we used to have atrazine, which was granulated. During those days, it was being sold by a company known as Spray Quip, which has since disappeared. Now, with that sort of atrazine, you could just broadcast it on the soil surface as if you are applying fertilizer. Then with the soil moisture, the herbicide could be released. Then it had a pre-emergence activity on the weeds. It was atrazine G, but it's now off the market. The beauty of atrazine G was that one could not require a sprayer and carry quantities of water, when you wanted to apply it. But of course, the downside of it is that you also need to carry this heavy bag of this solid or granule. So on that one, I'm not going to give you an example, but probably those who are in the industry may shed more light on the granulated pesticides. I'm sure there could be, insecticides which are granulated, which are soil applied. Then we have those who are in the form of pellets. Pellets are similar to granules in that they are ready to use. These may be applied by hand or machines. If being applied by hand, we expect safety precautions to be taken. Someone should wear gloves when applying these pesticides. They are used for soil treatment. One big advantage is that there is no drift, so drift is not a problem, it's an advantage. So you have a reduced application hazard. One of the pesticides, or some of the pesticides which are used as pellets, red poison. Normally we buy it as pellets, which you can use for domestic use in our houses, so that the rats may feed on the pellets. A wettable powder, WP or W, I don't like these ones, the wettable powders. Here you really need a mask. In fact, you need a mask when dealing with such pesticides. Although formulation in a way can minimize the risks depending on how the pesticide has been formulated, like granules, they appear to be a bit safe. Now this one, WP, this is a real danger, or W. This is finely ground solids, mineral clays containing active ingredients. Dry formulations look like dust. This is where the problem starts. They can get it to your nose and you start sneezing. And working with these kind of pesticides in the long term, you develop some problems of exposure to such kind of pesticides, especially where they are being manufactured, or in such type of environments. Workers really need protection. Wettable powders form suspensions in water and form true solutions, but they need constant shaking or agitation. These can also damage pumps because of the particles of clay. They can also damage nozzles. And as I've said, when mixing, this can be a real hazard. So if you see something, wettable powder or W, and you have got workers, there is need for serious, very serious precautions should be taken. This is WP 70% tribunal. Another oral herbicide. Sengo, we used to have a Sengo. This is the herbicide for soybean. We used to have these wettable powders. I think people have now shifted towards liquid formulations. SC maybe. We also used to have atrazine as a 80 WP wettable powder. So you had to weigh, the powder. You need a scale or some cups. So measuring wettable powders is also a hassle. I don't think this type of atrazine is commonly used nowadays. Diuron wettable powder, another oral herbicide in the form of dust or something. So this is so much for the wettable powders. SP in the beginning, I talked about SP as well, because they form true solutions. So these powders, if you mix them with water, they can easily become solutions. But I think the danger is when you are transferring the powder to the container which has got water. I think you need a mask to prevent contamination. However, when you put it in water, it can easily dissolve, and therefore agitation or shaking may not be necessary. It doesn't damage your sprayer, it's non-abrasive. But please note that because it is a powder, there is an inhalation hazard, and therefore masks should be worn so that somebody is not exposed to this pesticide. So remember, the way the pesticide is being formulated can also pose a risk. It can become a hazard as well to people who are using the pesticide, and they will need protection. There is something called water dispersible granule or dry flowable. It's called WDG or DF. These ones readily disperses in water to form a suspension. Constant agitation is required or mixing, but the good thing about water dispersible granule or dry flowable is that it's not like dust, so there's no inhalation hazard. But of course we should wear masks whenever we are using pesticides. But it can be abrasive to equipment, it can damage our nozzles and parts of the sprayer. We have got diuron, which is DF, dry flowable, but this nickel sulfure is 75 WDG, which is water dispersible granule. So these are some of the examples. Now I move on to talk a bit about some components within a pesticide which are not the active ingredient. They are just mixed with the active ingredient so that the pesticide is efficiently used. Different companies can use different, additives. This is the area where they can compete. How to package the pesticide and how to make it efficient. And in most cases, it can be a secret for the companies because they are competing. I don't know whether this is the case. So these spray adjuvants or additives or surfactants, they are added to improve herbicide efficacy or pesticide efficacy. You can have activators to improve pesticide efficacy after the spray has contacted the leaf surface. Utility adjuvants improve the ability to get the pesticide to the leaf surface. So these are some of the components which makes the pesticide efficient. Activator adjuvants. Water is a polar molecule with negative and positive charges. Water molecules are strongly attracted to each other than the surfaces they are in contact with. So water tends to run off the surfaces. It's a problem because if you spray water and you are using water as a media to deliver the pesticide, we are also likely to lose the droplets of water, they can run away from the pesticide, from the pest, which is our target. So no wonder why we have to put in some of these ingredients. For example, we need to put a wetting agent. You might have heard about wetting agents. They reduce surface tension. They flatten the droplets, which are circle in shape, so that they stay on the leaves. Surfactants, you know, they, like soap is a surfactant. So some products which look like soap could be used. I mean, this is the chemical nature of soap. So surfactants can improve herbicide performance. They are similar to soap, or they can make insecticides very toxic. This is the case where we have a droplet which is circular in shape, which can easily roll off the leaf and miss the target. If you then put a surfactant, you can flatten that droplet, making it stay where we want it. That is the reason why we put surfactants. We can also put what are known as stickers, which help the pesticide to stay on the leaf surface. It could be on the insect after water is evaporated. The herbicide can be efficiently absorbed, or the pesticide. Humectants. One of the problems when you apply droplets of water is evaporation, which makes the pesticide to become probably a solid, which will then fail to penetrate the target. So you need humectants which retain moisture and absorb water vapor. This can reduce evaporation, and which means the pesticide is in an active form. You prevent the herbicide from crystallizing, which is one of the problems with water which is evaporated. So you need to retain the moisture to prevent crystallization, forming a solid which cannot easily enter the pesticide. Increase absorption of herbicide into the leaf. This humectants. You also have penetrants. Surface of plant is a waxy cuticle. I'm going to talk about this as well at a certain point. So oil-soluble penetrating agent allows the pesticide to pass through the cuticle. So you need something which is going to break the cuticle to allow the entry of the pesticide. Drift control. As we spray the pesticides, they are likely to be carried away by the wind. So small droplets can be carried by the wind. So you need long chain molecules which reduce drift, which are added to the pesticide. Deformers. When you are working with the glyphosate, trying to pour it in a measuring cylinder, sometimes it creates a lot of foam, and you cannot read accurately the volume. But the addition of deformers, it will reduce this problem so that you can measure accurately the glyphosate. Colorants can also be added so that you can see the spray and also visualize the spray pattern so that you know where you have sprayed and the parts which have not been sprayed. They act like a guide. So this is it under formulation. I'll stop streaming.